Welcome back. In today's video, we are going to discuss how we can draw a correlation matrix heat map. Here is my heat map, and it's a correlation matrix heat map. We see that we are having the A, B, C, D, and E as the column label. Each column has its own label. So this is column A, this one is column B, column C, column D, and column E. And here we are having row A, row B, row C, row D, and row E. We would like to know the correlation between A and B, for example. For example, product A and product B, or the column the data A and the data B. So correlation is very important. So we see that for A and B, the correlation is negative. Okay, 0.14, negative 0.14. And then, for example, if we want to check something that is huge, the correlation is large. For example, we can see the correlation between E and B, and this is 0.69. So the correlation is very large, and we can say that the changes in E and B, for example, any changes that is happening in E can have impact on B, for example, because the correlation is huge. Okay. And also we can see, for example, between D and C, we are having a large coloration. Then, for example, we see that here we are having not a very large correlation. Here between D and E, the correlation is 0.18. And for example, D and E here they have no correlation, so they have no impact on each other. What these numbers mean? First of all, when we are discussing about correlation, when it is +1, so when the correlation is 1, it means that we are having positive correlation. So both variables increase together. So when one variable increases, the other one also increases. And this part we don't consider, the red part, because A of course has impact on A, so this part is negligible. And for the B and B, C and C, etc., we want to know the correlation between variables. Okay, so B and E, they are having a correlation of 0.69, meaning that the increase in B has impact on increase in E. So they both increase together. Okay. So when we are having -1 negative correlation, it means that when one increases, the other decreases. For example, when we check E and A, we see that the number is negative 0.09. So it means that an increase in E will lead to decrease in A. Okay, or another negative number, an increase in C will result in decrease in E. Okay, and this is the number of correlation. So this impact is larger than this impact because it's much closer to number -1. Then when we are having the correlation of 0, it means that we are having no correlation. So any changes in D has no impact on E. It's a very good way to understand uh, the impact of different variables. For example, an example could be during the COVID-19 pandemic, we could have the correlation between the uh, number of hospitalized people and number of death. So the increase in the number of hospitalized had a large correlation with the number of death. So this is one thing that we need to consider. So correlation is very important, but how we can have a correlation matrix heat map? Here, first of all, we are putting the seed in order to rerun the code to get the same result. Then we are having a matrix of 10 by 5. So we are having 5 column A, B, C, D, and E. And we are having 10 rows, 1, 2, 3, 4, 5, etc. Let me show you the table. So when I run the code now, I see here. So this is column A, column B, column C, D, and E. And these are different rows, 0, 1, 2, 3, etc. until the end. So we are having a matrix of 10 by 5, and this is our data. Okay, so this is our data that is being randomly generated between 0 and 1, and we are having 10 rows and 5 columns. Okay, and this matrix is assigned to df. Here we are calculating the correlation of this matrix. For example, when we were showing this matrix, let me show you again. We are having the first column to be 0.5 and negative 0.14 for A and B respectively. We see that the reduction in A, for example, is having the increase in B, for example. Then further reduction in A is having reduction in B. So we are going to have the correlation measurement one by one for each element to have an overall understanding of how changes in A can impact anything or any changes in B. And also for B and C, B and D, B and E, A and B, A and C, A and D, A and E, etc. So until the end, we are going to compute all the correlation and have an average over the correlation on the output. Okay, so this is the output that we want to get in the end. So we generated our uh, matrix and we assign it to df. Here we are calculating the correlation. So df dot corr, it is going to it's a correlation measurement that it is going to measure the relationship between two variables. And we said that if we are having, for example, +1, it means that it's a positive correlation. We are going to have negative correlation for -1, and 0 means no correlation. And the method by which we are doing the correlation here, usually we are using the Pearson correlation, which ranges between between -1, sorry, and 1. Okay, this is the figure size that we are having here. And now it's the time to plot our heat map. So I use the Seaborn library, and then I have the heatmap function. I write down the correlation matrix name because here we calculated the correlation matrix and we are assigning it to core underscore matrix, and we are having it to be shown. We are having the anode equals true, meaning that we are going to have these numbers. So if I remove this part, you will see that we don't have these numbers on the cells. Okay, you see that we have no numbers, so we still can understand. For example, negative 0.2 is this number, so this is having a negative correlation, these two, and the ones that are like this are having more correlation because they are somewhere between 0.6 and 0.8. But in order to understand it better, it's easier to have the numbers on the cells, let's say. So we are going to use the anode equals true to have the numbers on the cell. So it's very easy to understand the correlation rather than trying to understand the color scale. We are choosing the color map here. We choose cool warm. We are mentioning that all the numbers that are shown here, show them with 2 decimals. So .2f means 2 decimals. We are having 1.00, 1.00, 0.47, etc. So everything is shown there. Also, this is the line width. For example, now I choose it to be 0.5, but if I increase this number, for example, 2.5, you see that we are having a larger edges width here. So it depends on what we are looking for. We can customize this one as well. You see, it's now smaller. And here finally is the title of our heat map. We are saying that correlation matrix heat map. We are having this font size and we are having it being bold. And we are displaying our plot here. So in this video, we learned how we can generate a table or let's say a matrix with different columns, 5 columns and different numbers. And then we measure the correlation between any two variables. Using the core function, we assign it to a new core matrix variable, and then this is shown, which is our table here. Okay, it shows, for example, any changes in A, how it's going to impact on B, or on C or D, and any other variables. For example, B, when it is increasing, C it is going to decrease. Also, A it is going to decrease, and also D is going to decrease, but E is going to increase, for example. This is what we learned in this video, and also we learned how to plot a correlation matrix in Python. Thank you for watching.